Welcome to the Open Mainframe Project stream in Virtual Room 4. My name is Mamelin Meaner, and I'm the Director of PR and Communications at the Linux Foundation and Chair of this session. This session code is 4Q, Q is in quiet, and is titled The Mixing Python and COBOL, presented by Stephen Pittman, compiler developer at IBM. Just a few quick housekeeping notes before we get started. This session is being recorded and will be available after the conference. If you have questions, please submit them in the chat window. Then after the presentation, we ask that you please provide session feedback online from the links on the agenda or by scanning the QR code on the last page of the presentation. With that, I will hand it over to you, Stephen.
All right. So hello, everyone. So I'm Stephen Pittman. I'm the technical lead for the IBM Open Enterprise SDK for Python. And so that's just Python running on ZOS. So today I'm going to be presenting to you guys how to do interoperability between Python and COBOL. So a few days ago, I had given the introduction to Python. So like, how do you interact with it in various ZOS languages and other environments? So like the ZOS container platform or running it from batch. So if that interests you, you can kind of find the slides on the GSUK website. But today we're going to be interacting with already existing code on your system. So it's how do you call Python from COBOL and how do you call COBOL from Python? And we're going to look at it from both the same or different address spaces. So let's take a look at our agenda. Then we can get started. So first up, we're going to go over the motivation for doing this presentation. Then we'll take a quick look at Python itself, kind of what's in the offering. Then we're also going to be looking at the COBOL offering as well. And then we'll get started with the more interesting part of the session. So we'll be going over, interoperability in the different languages. We'll kind of start with the easy stuff, which is like having the new address space. And then we'll cover the more difficult part, which is when you need them in the same address space. So motivation. So why am I giving this talk today? So the main reason is that we have tons of clients, and these clients have written tons of COBOL over the past decade, and they don't really want to be throwing away their investment or rewriting it in different languages, like C or C++, or the newer languages like Python or Go. What would kind of be ideal is that they can simply just call Python from their already existing code, and in this way they get access to the best parts of Python and the best parts of their already existing COBOL code, that it exists, it's already written. So what are the best parts of Python though? Python excels in a few key domains, such as doing AI, it's doing machine learning, automation, data analysis, and a whole bunch more really. But the Python community has hundreds of thousands of packages that they already have available for use. And these cover a huge number of use cases. And as they say, don't reinvent the wheel. Use what's already been created. So if you need support for some of these key packages, like we often hear about NumPy or Pandas, all of these are available within the Python AI toolkit. So you can get support for these packages if that's needed. Now, let's talk about the Python interpreter briefly. So the Python interpreter is running under Unix System Services, so it's a Unix application. It contains everything that you need to get started with Python. So it's got the standard library, it's got a few extra tooling, and a few of them I've listed here. So like pip is for building, installing, and uninstalling your packages into your Python environment. We got VF, which is virtual environments, and it's for isolating your Python environment so that you don't get dependency conflicts. It kind of just keeps your packages separate. Cryptography is so that you can do cryptographic related tasks, and CFFI is for calling shared libraries on your system. We did add a few extra features though. So if you've ever worked on ZOS, there's various encodings that are used. You might have files encoded in EBCDIC. They might be encoded in ASCII. So we've added auto conversion to Python. So your scripts can be in either EBCDIC or ASCII. But additionally, if you're just like reading files, it's just going to naturally work, regardless of if that's ASCII or EBCDIC. We've also added a few additional encodings, so most of these are just the EBCDIC related ones. And we've also added ZEDC support. So ZEDC, it's hardware for doing compression and decompression of your archive files. So instead of doing compression in software, it's going to be done in hardware. Now, there's two currently supported releases, which is Python 3.12 and 3.13. And these support all Z CPU generations and all ZOS versions. So if what you're running is on the supported hardware and software, I guess, Python, it's just going to run there as well. But if you do have a zip processor on your Z system, and you've got the latest PTFs installed for Python, Python's going to be eligible to be offloaded to your zip for up to 70% of its runtime. Now, not everything is offloadable, so you can head to our docs to find out what is eligible. So we list them out. Now, finally, Python's easy to obtain for your systems. So you can just grab it off ShopC with an SMP down or download the PAX archive and just transfer it to your machine. We do have a new way of obtaining it though, which is the ZOS container platform image. So if you want to containerize your Python workloads, there's a pre-made container for doing just this and to get you started. So it contains like a C and C++ compiler, so it's everything that you need. Now, one thing to note though, Python is also a bypassable requisite for ZOS. So when you're ordering ZOS, you can just have Python included in that order, and it's just kind of much easier to order. Now, finally, this is all available with no charge license, no charge subscription and support. So you just obtain Python and you're good to go. Now, the IBM Enterprise COBOL for ZOS, it's a COBOL compiler. So there's currently two supported versions, which is version 6.3 and 6.4. The same as Python, it runs on all supported versions of ZOS and your CPU models. But COBOL is a high-level language, and its main goal was that it kind of reads like English does. So while it's a bit familiar to more recent programming languages, there have been features to improve on that, so it kind of is easier to read now. But unlike Python, the COBOL compiler actually runs in different environments. So you could compile your COBOL from Unix system services, or you could do it from batch, but it has direct interoperability with other high-level languages like Java. And today I'm going to be showing how you can do that with like Python. But finally, it's available via ShopZ as well, and it has MLC and VUE options available for it. Now, before I actually start doing the types of interoperability, I just want to make sure that everyone kind of knows what I'm talking about. So I know some people here are going to be more familiar with Unix. Some of them are going to be more familiar with like traditional MVS. So let's kind of get on the same page. So I'm going to be talking about address spaces on ZOS. So I wanted to explain that specifically. So an address space is roughly the same concept as a process on Unix. It kind of tracks what kind of code you're executing. It's the data that's used during the execution. And it also has the same kind of concepts like multiple tasks per address space. So kind of similar to multi-threading. So if you're new to ZOS, just keep that in mind that an address space is roughly a process. So same concept. Now, there's a few different ways that you can do interoperability. So first off is that you can spawn a new process in each of the various languages, and you could, for example, just pass data between like files or something. So while I'll show you an example of doing this for each language, it's not really going to be the focus of this session. So we're going to be spending some more time on directly calling another language's functions in the same address space. But one thing that you may have picked up on is the COBOL is a compiled language, and so you compile your source code down to a binary, and then you kind of run that. Python's an interpreted language. It doesn't get compiled. So kind of how does that work? How do we mix those? So after we do a few examples, though, of spawning new processes, so that easier section, we'll come back and we'll actually answer that question. So let's start easy with Python calling COBOL. So this is with a new address space. So Python standard library comes with a bunch of ways that you can spawn a new subprocess. So there's packages dedicated just to this, like subprocess, but you can also just use the others, like such as the OS package, and just doing, your traditional fork and exec. But today I'm just going to show you how to use the subprocess package. On the flip side, though, if you're in COBOL, you can interact with the various C APIs, so such as like fork and exec. If you're not familiar with these, though, fork is used to create a copy of your process, and exec is to replace it with another running process. So you would just fork to create the child process, then exec to replace it with some other one. Now, there's a concept called A mode on ZOS. It refers to addressing mode. So this specifies the length of addresses that programs can actually use. And there's kind of a couple key ones, which is 64-bit, there's 31-bit, and 24-bit. In all of the upcoming demos that I'm going to be working in either 31 or 64-bit, but in this case of the first examples, you're going to be spawning a new, like a process in the new address space. So it doesn't actually matter what your program is using. But however, one thing is to note is that Python's always a 64-bit application. But the COBOL that you compile, it can be the same or it could be others like 31 or 24. All right, so for our first demo, we're going to start really at the very basics. So I'm just going to show you how do you start a new process with Python, so called some COBOL code, and we're going to do the inverse. So it's how do you call Python from COBOL. Let me load this. Okay, so the way I've got most of these demos structured is that I have a shell script, and that's just going to be executing all of our programs. So it'll compile any of the COBOL files that we have, and it's going to be running Python or COBOL, depending on the example. So this first example that we're going to start with, we're going to start with Python, and it's going to be running COBOL. So let's kind of look through each line just so that I can explain it and you can kind of understand it. So the first part is it's just going to do some cleanup. So when we compile some COBOL files, there's going to be some temporary files left over. We're just going to clean it up so it's all fresh. Next up, we're going to build our COBOL binary. So all we're going to be doing is taking a file called run.cobol, and we're going to produce our binary called run.cobol. Next up, to run Python, we require some environment variables. So you can see this first one, path and libpath. Path is for finding where we can find the binaries that are required for Python. Libpath is so it can find the shared libraries. This next one, BPXK autoconversion. This is just so you can do autoconversion between encodings. So specifically EBCDIC and ASCII for us. And then the CE runops, the final environment variable. Python's a POSIX application, so we want to enable POSIX. But also when it's creating files, so like if you write to some brand new file, we also want to make sure that it's the correct encoding and tag that file correctly. So we're going to enable that. But finally, you can see at the end, we're just going to run some Python, and then that Python is going to call this new COBOL program that we just compiled here. So let's take a look at the COBOL first. I'm not going to explain every single line, but there's a few key ones that are going to matter for this and the previous or the following demos. So the main parts that matter, it really is this working storage section. So that's going to be where we're going to put a lot of our variables. And then the next part is going to be this procedure division. So that's going to be where we run our code. We're also going to give this program a name. So how do we actually call this program? But you can see in this case, all we're going to do is say, we're going to display hello world. So it's going to be a very simple example. We're just going to run hello world from Python, more or less. So looking at the Python though, we're going to import this subprocess module. And then that subprocess module lets us spawn new processes. And so the easiest way you can actually do this is this check output function. And so it runs your program and it returns the output. So at this point, we're just going to print out whatever our COBOL program printed out, and then that's just going to be hello world. So when I run all of this, what we expect to see is that it's going to compile the COBOL, then it's going to run Python, which runs a subprocess of the COBOL, and then it'll print out hello world. So let's do that. And you can see here at the very bottom, we ran our Python script. It says hello world, and that came from the COBOL. So really simple stuff. Let's move on to doing the same, but we'll start with COBOL. So the goal for this one is that we're going to take COBOL, we're going to run a subprocess, which is just Python. And we'll kind of do the same. So you can see Pretty much everything here is all the same. We're going to compile our COBOL module. We'll set our environment variables that are required for Python, and then we're going to run COBOL. So if we take a look at our COBOL, it is a bit more complicated, but here's main things that I want to get across to you guys, which is we're going to call fork. So we're going to create our subprocess. We're then gonna, if we go down here, we're gonna run exec. So this is gonna be within the child. It's gonna replace exec with Python. And you can see that I've specified the Python binary here and the script that it's gonna run here. So it's gonna say spawn a new process and then run Python with some given script. And that's really about it. So let's take a look at the Python script. Dead simple once
Stephen,
again.
I'm gonna
Yeah,
interrupt you real quick. We do have a question from Ian.
yeah.
He asked, running COBOL from Python, how do you get the COBOL binary from an existing load lab instead of compiling it?
Okay, so there's a package called ZOAU. So if you wanted to run it from like um, like somewhere that's not on Unix system services, you should be able to use ZOAU to be able to do that. I don't have a demo for actually doing that though, but you could run it, if you're going to use batch, you can run it with JCL and ZOAU will help you run that. Um, it's quite similar where you can say, oh, do I want to get the output or, you know, redirect your outputs to a given data set or a Unix file. So it's similar, but you can see the previous demo from a few days ago. And I give examples of how to actually do that. So right now we're just working within Unix. Okay. Um, so if that answered the question, then we can just continue. And so if you look here, the Python code that we're going to be running from COBOL is just, it's hello world again. We're just going to print it out, and that's what you're going to see. So just to recap, we're going to compile some COBOL. We'll run that COBOL, and that COBOL is going to call Python, which will print out hello world. So it should be quite simple once again. Nope, I'm in the wrong directory, sorry. And there you have it. So we ran the COBOL, it prints out hello world, which came from Python. So that's the very easy stuff. Let's start covering the stuff where it's the same address space now. So I had previously discussed address spaces, which is when you have like a 64-bit or 31-bit or 21-bit A modes. If you're trying to call a function that has the same A mode, then for the most part, as long as it's a DLL, it's kind of a non-issue. However, in the case of COBOL and Python, a lot of clients' COBOL code, it tends to be written as 31-bit. And because of that, you cannot directly call Python from there, because we recall Python is 64-bit. That being said, though, there is a thing in ZOS called LE, which is the language environment. LE provides a bunch of APIs that we can call. And one of those is called cell row 31, or cell for row 31. And this allows us to call 31-bit functions from a 64-bit one. So likewise, the inverse is also true, which you can call a 64-bit function from a 31-bit one using cell for row 64 instead. However, in this session, we're going to be going over both types of examples. So we're going to be directly calling functions that are the same A mode, and we're going to be calling ones that are different A modes. All right, so our first example is going to be Python calling a 64-bit COBOL program. So which means that they're going to be the same A mode. So within the Python standard library, you got two packages that are called CFFI and ctypes. So these packages let you load up a shared library and to be able to call functions that are declared in it. So that's one method that we can use. Another method that we could use is Python allows you to write packages, and those packages don't have to actually be written in Python. So for example, it's very common to write in a Python package in like C or C++. So if you wrote a package in that language, you'd be able to just directly call your COBOL from it. So there isn't actually support for it, but it should be technically possible to just write your package with COBOL instead, but we haven't taken a look at that yet. But if you take a look at the bottom of the screen, uh, we're going to be taking a look at that, taking that first approach. So that's going to be using C types from within Python and just directly calling the COBOL. It's kind of the simplest method. Now, if we started with 64-bit COBOL and wanted to call Python, how would we do that? Well, Python has its own C API. So it comes as a shared library with a side deck. And so because of that, you can just link you can link your COBOL programs with it. Because of this, you can just call Python C API, set up the interpreter, run whatever program you want directly within COBOL, uh, and then just tear it down, do your cleanup. One restriction to note, though, is that your COBOL must be compiled as a DLL, however. So let's kind of do a demo of these first two cases. So these are when it is the same A modes. So I'll be showing what it's like for Python to be calling that 64-bit COBOL and kind of the inverse of calling Python from a 64-bit COBOL. So first up, it's all the same. So I have my execute script. We're gonna look at the exact, or we've already seen all this, the environment variables that are set up for Python, so we don't need to go over those. The next up is we're going to compile our COBOL program. And there's a few key flags that I want to point out. So the first one is this Q64. It's going to specify, we want a 64-bit COBOL application. The next one is we're going to compile it as a DLL. So that was just one of our requirements. Next up, the last thing I want to point out is we want the Python's side deck. So when we compile the COBOL, it knows where to find these function names. Once you're done that, we can just run our COBOL program. And so for this first demo, we're going to be looking at COBOL calling Python. So we'll see the Python code embedded within COBOL. So if we take a look at the COBOL now, it's actually really quite simple again. So you can see here, if we go to the procedure division, we're going to call PyInitialize. So that sets up our Python interpreter. We're going to call this run simple string. And so that's going to just take in Python code directly. So if you see above here, we're going to take in the variable run. That's just going to say print hello world. And so all this program is going to do is it's going to set up the interpreter. It'll run hello world. And then finally, it's just going to call PyFinalize. And so that shuts down the Python interpreter. So at the end, we should just see hello world, and that's coming from Python. So let me run that. And you can see it just runs hello world. So as long as we're working with the same A modes, it's actually really quite simple to be working between COBOL and Python. So let's take a look at the next example though, which is going to be having Python call COBOL directly. So if we look at our execute script, it's pretty much exactly the same. We got some environment variables for Python. We're going to compile our COBOL module. Again, it's going to be 64-bit. It's going to be a DLL. And then we're just going to run our Python script. So first, let's take a look at the COBOL. This is just a really simple program, but I just wanted to demonstrate passing in parameters this time. And so you can see all we're going to do is that we have two main parameters for this one. And all it's going to do is it's going to add them and then return that. And so it's a very simple function of add two numbers. So if we take a look at the Python code now, this is actually what C types looks like. So you can see that we import C types. We load up our shared library that we had just compiled. And then here we specify what does the function actually look like. And so we have, two arguments that are going to be passed into it. And then it's also going to return an argument. So when we add two numbers, it'll return it. And then at this point, we're able to just call that function. And so that we're going to pass in 5 and 6. So it's going to add them together. And then we should see that it prints out 11. So let's do that. And so there you go. So it ran our or it compiled our COBOL code. It ran the Python, which ran our COBOL and printed out 11. So at that point, when we're working with the same A modes, you've kind of seen the examples. How do you call Python from COBOL? How do you call COBOL from Python? So let's go back to the slides. Okay. So let's kind of look at the more difficult case now of calling 31-bit COBOL from Python. So I previously mentioned that Python lets you write packages from written in C. And because of this, we can take advantage of those LE services. So specifically the cell4 row 31, which lets us call those 31-bit applications. So if you look at the overall flow of the bottom of the slide, it goes from Python to C, which is 64-bit C. Then in C, we're going to use that cell4 row 31 to call our 31-bit COBOL. So at that point, your COBOL can just be doing whatever it needs to. So that's kind of what the overall flow looks like from the Python's direction. For the last sample, we're going to take a look at 31-bit COBOL that's calling 64-bit Python. One of the really nice features of COBOL that COBOL has built in is that if it's 31-bit, it can actually just dynamically call 64-bit functions, making COBOL actually very simple to use for this case. It does have a one restriction, however, which is that if the function being called resides in a ZOS dataset, uh, it it must reside in a ZOS dataset, sorry. So it cannot exist within Unix system services. But again, if you look at the flow, the way that it works is that you just have a 31-bit COBOL program. It just calls a 64-bit COBOL program, which can then just call any of your C API, the Python C API functions. So let's actually take a look at some samples of doing these. So it's going to be Python calling 31-bit COBOL, and then we'll look at 31-bit COBOL calling Python. So let's take a look at our execute script. So it's actually a fair bit larger this time. So let's actually kind of walk through it. So these initial steps, it's just going to be cleaning up some temporary files. So we can largely ignore that. You've seen all environment variables required for Python. This next one is going to be a virtual environment. So I had kind of explained it, but basically when you create a virtual environment, it's going to separate it from your root install. So it's like, it basically gives you a completely fresh Python environment. And so that's kind of what we want, just like a clean environment for building this project. So we're going to create our virtual environment, we're going to use it, and then we're going to compile our COBOL module program, I guess. It's just going to be a shared library. So this first case that we're looking at, it's going to be Python calling 31-bit COBOL. So you'll notice there's no -Q64 here. Then, in this case, since we're going to be creating a Python package, we're just going to use pip to install this package, which we'll take a look at shortly. And then finally, we're pretty much ready to go. So we're just going to import that package, like when we run our Python, and we're going to print out calling COBOL. So we'll look at COBOL in a second, but it's simply the exact same program, but in 31-bit this time. So it's going to add two numbers, it's going to return it. And so basically it looks pretty much identical to what you had seen in the previous demo. So there's nothing really here. But since we are creating a Python package, let's actually look at what that looks like. So within each Python package, there's a standard tool called setup tools. And when you have a setup tools, or when you're using setup tools, you create a setup.py and you create whatever, or you add whatever source you need. So if you look at the setup.py, all it does is it describes your package. So we just import some of the things we need, and then you can see we're going to create a package called call COBOL. You give it a version, and then you also specify what are the sources that we require to build this package. And in this case, it's just where you have a C file. So if we take a look at that C file, it's actually really long because using that cell4 row 31, it's actually, it requires some setup. But all of this in setup is documented on the IBM's website. So they give you a full example. So I don't need dive deep into this, but there are a few things that I wanted to show you within this file. So if we go down, the main parts are that this PyInit, the COBOL, that's what's running when you're actually going to be initializing it from your Python code. This struct here is going to describe what does your module or the package actually look like. So like what's its name, what are the methods that it contains, and all this kind of stuff. In this case, the methods is just a function called call COBOL. But if we look up here, so this I have a function called call test 31-bit. This is what uses that cell for row 31. And specifically, the part that matters is that it's going to load up our cob test, the shared library, and then we have a function, cob test. And down here, yes, we're actually going to be running that function. So everything above this is just going to be saying this is set up to actually run our function. But let's actually run it. So, oops. Okay, so this is actually going to take a moment because we're going to be creating a virtual environment. We're going to be compiling some COBOL, compiling some C. It's building a package and then running it. But it should be almost done. But the main case, just to recap, it builds a Python package. We're going to use that package and it's going to drop to C. Or sorry, it's going to be able to run our Python. It'll drop to C. And then that C is going to call the LE API to call our 31-bit COBOL. And you can see here at the bottom, we had passed in 2 numbers from our scripts, which I'll show you. It's this statement right here. So we passed in 5 and 6. It added them and returned 11. So that's kind of what it looks like to call 31-bit COBOL from Python. One thing I want to note though is that within my slides, I do have a resource page, and it contains all of these samples to actually do all these things. So while I'm kind of skipping over or glossing over a bit of the details, it's all available for you. We have it all on GitHub, and you can just view it whenever you need it. But let's take a look at the final sample now, which is going to be 31-bit COBOL that's calling 64-bit Python. So it's actually a fair bit easier, but let's just go over the scripts. So first up, we're going to compile 2 COBOL files. This first one is going to be our 31-bit one. The next one is going to be our 64-bit one. But if you recall, I mentioned that we're going to be that 64-bit one, so the callee has to be in a data set. And so that's all I'm going to do. I'm just going to copy it over to a data set so that we can run it. And then we'll add that to our step lib, and it's pretty much good to go. One final thing to note, though, is that if you want to actually be able to call a 64-bit COBOL program from 31-bit, you need this environment variable. And so that just specifies, yes, you can do that. But at that point, we're ready to run our COBOL. So let's take a look at both COBOL files, and then we'll run it. And that's pretty much the demo. So this first one, this one's going to be our 31-bit COBOL program. And so we want to be able to just call the other one. And so all we do is say we're going to move a name into the program name. So that's the variable that we've got described above. And then we're just going to call it. And that's all you got to do to be able to call your 64-bit program from 31-bit in COBOL. So really quite simple. If you take a look at this dynamic callee, this is actually very similar to that other program, just with a different name, or a previous demo, I should say. And so all it's going to do is it'll initialize our Python interpreter. So this line, we're going to run some Python code, and then finally we'll tear everything down, do our cleanup within Python. And that's it. So once we actually run this code, all it's going to say is print hello world, and we should be good. So let's run that. Okay, so you can see here that it's compiled the both COBOL files, and at the very bottom, so looking at the terminal, we got hello world. So we know that we can call our 64-bit program from that 31-bit one. So let's go back to the slides. So let's just kind of recap. And today I've covered kind of the topic of how do you do interoperability between Python and COBOL. And we've looked at quite a few different scenarios. So we've gone over lots of examples, a few concepts. But the one thing that I wanted to get across to you guys is that all these things are possible and kind of how you can do them. You may not need this like right away, but you can refer back to this presentation. You can refer back to the slides or look at the GitHub code. And if you need to do this, you can. So I've got some resources for you guys here. A lot of the demo, it's got blog posts from. We've shared this code on GitHub, so you can get access to it all. It's all here. I don't believe I've uploaded these slides to GSUK just yet, but I'll do so after the presentation, so you can get access to them. Now, I'm from the compiler group at IBM, and we do have another presentation that's going on later today. So my colleague Bill's going to be presenting about the Go language later today. So if you're interested about learning about that language, I'd encourage you to go attend. And finally, so please leave some feedback. So any feedback is good feedback. The session code is 4Q, but you can additionally just scan that QR code. But anyway, but with that, if you got any questions, then we can take them now. I believe we got just a few minutes, so.
Nope. If you have any questions, please just add it to the chat. Steve asks, how about PL1?
PL1, so I don't have actually any experience with doing that from Python, so if you get in contact with us, we can take a look.
And then Wendell had a comment, but you're gonna have to read it.
Oh, okay.
It
Uh,
seems like it's code or something.
okay, so Wendell was asking it about the uh, copying the data set. So let me show you what he's asking. So when we say copy this Dyncolly to a data set, this is the syntax that you actually use to copy a file to a data set. So this slash slash says, it's a ZOS data set, and then everything that goes in here is what the data set's name is. So that's not using ZOU, that's just using straight the copy command that comes with ZOS. Yeah,
Awesome. Any other questions? Okay. Great. Well, thank you, Stephen. As always, it was a really good presentation. And thank you all for attending. We just ask you again to please leave your feedback for the session. You can either use this link or the QR code that Stephen has.
all right. Well, thanks for attending, everyone. Have a good day.
Thank you.